Hi, everyone. Thank you for joining this public training session. My name is Brandon, and thank you, Master VRRP, for your introduction and demonstration of how VSU works. Now, I will be showing you guys the following. Let me just share my screen here. Can you all see my screen?
Yes, we can see.
Okay, thank you. All right, so today's global public training will be covering VRRP and MSTP principles. So we'll start off with VRRP principles, and then we'll move on to MST principles, and then we'll cover lab to show you guys how to use these two protocols in combination. So first of all, what does VRRP stand for? Well, as you guys can see, VRRP stands for Virtual Router Redundancy Protocol. And I think the key word in this whole abbreviation here is router. Router indicates layer 3 connectivity. So for VRRP to be able to work, you will require either a router or a layer 3 switch. So this is a layer 3 technology. Right. So what are some advantages for VRRP? Well, VRRP, the advantages are high availability, load balancing, redundancy, ease of configuration, and scalability, and fast failover. All right. Just to show you guys some background for VRRP. So this is a normal network topology that we all might be familiar with. So let's, for example, say there's another VLAN connected to the switch here. So let's just say VLAN 30. And as you can see here, the gateway for the PCs all point to this switch over here, which is a layer 3 switch. So it acts as the gateway for these networks. So if this layer switch 3 should break down and fail, this means that both of these PCs will not be able to reach the external network or have any inter-VLAN routing. They will be stuck on their local VLAN that they are connected to and only communicate with devices connected on their network. So what VRRP is able to do, so this is VRRP addresses this problem with the following topology. So as you guys can see here, now we have two layer 3 switches. And as mentioned 2 slides back, it is important that this has to be a layer 3 capable device. Right, so now we have two layer 3 switches. We once again have two computers. Let's say these computers have the same gateway of 10.1.1.1, right? And now you have two switches, and you will configure them in a VRRP backup group. So what happens when you configure them in a VRRP backup group is they will actually communicate with each other. And with all the parameters that you have established, they will create a virtual router. So what will happen now, once this virtual router has been created, if you have configured it correctly, it will take the IP address for the gateway of the network. So the virtual router's IP address will actually become 10.1.1.1. So this is a virtual router, so we're just going to call it VR. So now, in your VRRP backup group where switch A and switch B belongs to, with the specifications that you have configured, which we'll touch on in the following slide, there will be a master device and a backup device, right? So if the master device will actually become the owner of the virtual router. So I like calling this router over here a floating router, and it will attach itself to the master device. So what will happen here is this router will attach itself to this router on this side. And now when your computers are looking for their gateway, they will actually flow in this direction to communicate with the gateway. But if this switch fails, then the backup router will automatically become the master router. And the virtual or the floating router, as I like calling it, will attach itself to the backup router that is now the master router. So what will happen is, let me show you guys. Now the traffic will flow from this PC to this switch, as this has become the new master router. If I am going too quick for you guys have any questions, please do let me know. you can just stop me or just send a message and I will respond to it. Right. So VRRP concept. So this is how you would actually configure the VRRP. So if you look at this topology here, I think the first thing that we need to note is we need to take into consideration what is here. And we can see that there are 3 PCs and all of these PCs are configured on VLAN 10. Now that these computers are configured on VLAN 10, we look at their gateways and we can see their gateway is 192.168.10.254. But if we look at our layer 3 switches, we can see that not one of these 2 switches have that IP address. This one is 10.252 and this one is 10.253. So that means they will be configured in a VRRP group. So what's important to note for VRRP backup groups to actually work, they have to be in the same network and same broadcast domain. So they have to be on the same VLAN and they have to have IP addresses within the same subnet. So you can see on this side here, this switch belongs to SVI. SVI switch virtual interface, that's what it stands for, is SVI 10, and it has the IP address of 192.168.10.252. And on switch B, we also have SVI 10, which means they are on the same broadcast domain. And by the IP address, it's very rare that it won't be the same IP range. So this is definitely the same IP range, so they can communicate with each other. So they'll be able to send packets to one another. Now that you have all of this confirmed, you can configure a VRID. Once you've configured a VRID, and this is important to note that the VRIDs have to be the same for a VRRP backup group. You can have multiple VRRP backup groups. You can have a VRRP backup group for SVI 10, SVI 20, SVI 30, or however many you require for your network. So, but if you want them to be the same, they have to belong to the same VRID group. Highest priority will become the master device. Right. So it will become the master device of the network. And then the default priority value is 100. So this is the default priority value, as you can see on this side here. Okay, once you've configured the priority, you can actually configure the virtual IP address. So the virtual IP address will be the gateway of the network. So as I've mentioned earlier, the IP address for the gateway for the PCs at the bottom here point to 10.254. And now we actually have that IP present on the network, as you can see here. So 192.168.10.254. Once you've configured all of this, a virtual router will be created. Once the virtual router is created, you will get your master role. And as I've mentioned, the one with the highest priority will become the master, and the other router will become a backup router, as you can see on this slide here. Now, this virtual address or virtual router or floating router will attach itself to the master device. Okay. So now that we are quite familiar with this topology over here, here are some interesting facts that we need to know. So a VRRP backup group. A group of routers running VRRP protocol divided together called a backup group is functionally equivalent to a virtual router. So yes, so once you have the same VRID group and all of that, these 2 routers will work together, but a virtual router will be created between them. What makes VRRP different from VSU, which VRDAM has explained to us, is you still have 2 different devices. They will not become one unit. They will work together independently, but with a virtual router between them for failover purposes. And this just indicates that you need to ensure that they are linked to the same SVI and that they are on the same network as I mentioned earlier. All right, the VRID. So you have a range for VRID groups of 1 to 255. So you can have 255 VRID groups in total. So you can't have as many as what you want, which I think I mentioned a bit earlier. You can only have 255, but I think that's plenty. I don't think there would be a network that we will work on that will exceed that amount. So important to note that the VR ID has to be the same for the switches or the routers to be considered as the same backup group. And then you have a virtual IP address and a virtual MAC address. So what is important to note is that when the virtual IP address is created, so this is the virtual IP address that you've created, obviously it's created on the virtual router, and that router attaches itself to the master device. But now what's interesting is that this virtual IP address has its own MAC address of 00-00-5E-00-01. This MAC address will actually be shown in these PC's ARP tables. ARP tables, right? So if you do an ARP lookup, you will find the gateway address with this MAC address linked to it. The VRRP will not actually use the MAC address of the interface of the master switch. Okay, then you get two roles. You get your backup role and your master role. So important to note that the master router will actually be handling the routing traffic. So it will handle the forwarding of the packets, where the backup router is just in listening state. So what this means is that the master router will constantly send hello messages every 3 seconds or so, hello messages to the backup router, and the backup router will just listen for these messages. If it doesn't receive a hello message, it will then take over the master role. Okay, so priorities. Like I've mentioned with priorities, the highest priority will become the active router or the master router, as you can see there. Your priorities can go from 0 to 255 as well. If, like I've mentioned earlier, the default value or the default priority is 100. So if we look at this scenario here, and let's say this priority was never set to 110 and it was left a default, so 100. What will VRRP do in this instance here? Well, VRRP will go and it will see, okay, the priorities are the same. So what it will do is it will compare the IP addresses, and it will actually take the device with the highest IP address to become the master router. So in this scenario that we see here, this device has the highest IP address of 253, and it's higher than 252. So this backup device would actually have become the master device if the priorities were left to default. Like I've mentioned, default priority is 100. And then some important thing to note is, let me just clear the writing here. Okay, some important thing to note is you can physically change the IP address of switch A, for example, to 254, which is the gateway of the network. All right. So what will happen if you do this is this switch will be seen as the IP owner. And if it is the IP owner, its priority will by default change to 255, which is the highest priority. So this router will then automatically become the priority or the master router of the VRRP. And it will also be the IP owner, but VRRP will still be working. So if this router fails, then this virtual IP address will attach itself to the backup router. Preemption mode. So if preemption mode is turned off, the high priority backup router will not actively become the active router, even if the active router has a lower priority, and the backup router will become the primary router only when the active router fails. So preemption mode is just a way to ensure that the device of the highest priority remains the master. So for example, if preemption mode was turned off and you want your backup router to become the active router or the master router, and you go and change the priority here to, so this is, let me just do this again. Okay, so you go change the priority to 200 because this one is 150. Then if preemption mode was turned off, this router would still not have become the master router. Only if the master router has failed, the backup router would have become the master router. So preemption mode is to ensure that the high priority router is the master router, and by default preemption mode is turned on. Okay, so VRRP working principles. First of all, you get two routers that discover each other with VRRP packets, so they send hello messages to one another. Once they've sent hello messages to one another and the configuration is correct, they will create the virtual router. Now that they've created the virtual router, they will compare their IP addresses and their priorities that were assigned to them. So what we can assume from this topology here is this router is 10.1.1.2 and this is 10.1.1.3. So I assume that they kept the default priorities of 100 because this router became the master, the one of the highest IP address. So it might be wrong, but it's just an assumption that this became the master. PCs on the network, their gateways will actually point to the virtual IP address equals virtual IP. And then once the master router fails, the switching or the conversion from backup to master will happen automatically. So VRRP packets. VRRP messages are multicast messages that are sent by the master router at regular intervals. Using VRRP message to detect various parameters of virtual routers for master router election. Virtual packets are carried on top of the IP packets using protocol number 112. The multicast IP address used for VRRP packets is 224.0.0.18. Okay. Then you get three states for VRRP. So there are three states. So it's initializing, master, and backup. And this is actually very easy to understand. Initializing state, a device can only be an initializing state once it's turned on or busy restarting. Then it's in initializing state. After initializing state, it will either become a master device, and if it becomes the master of the device, it becomes the device that will actively forward the packet. So it becomes the IP owner, first of all, IP owner, and it will actively forward the routing packets. And if you go into backup mode, you do not become the IP owner. You go into listening mode, and you continuously listen for messages from the master device. And if the master device does not send you a message, you will become the master router. So, how do you go from a master state or a backup state into initializing state? Well, that's if you receive a shutdown message. So if you shut down, you have to start up and you will go into initializing state. How do you go from a master state into backup state? That's if you receive a priority packet from the backup router that the backup router's priority has actually been made higher. So what that just means is if this is 150 and this is 100, and you manually go change the configuration to 200 for the priority of the backup router, then the backup router will actually send a VRRP packet to the master router. So the master router will receive a packet that the backup router has a higher priority, and the master router will change into backup state. And how do you go from a backup state into master state? Well, that's if you don't receive a hello message from the master router within a set time, or if your priority has manually been made higher. That's the only two ways. Okay. Then VRRP interface tracking. I think this is a very good concept, and it addresses one of the problems you might have with VRRP. So if you look at this topology here, VRRP is running between these two routers on this side, and they both have an internet connection to the ISP, which is fine. But now they communicate on the LAN level with each other. So if this device is active, they will continuously send packets in this direction. Right, so the master router will say hello, and this device will receive it. So if the network is fine, traffic will flow like this, and it will go out to the internet, and that's working. But now what happens if this interface is disabled, or this link is broken, or this the interface is disabled or this broken. What will happen now? Now all your traffic is flowing to the left, to the master router on the left-hand side, but it will not be able to reach the ISP or the internet or whatever might be over this link. And the VRRP will not detect that this router is offline because it's not offline. It's still online and it's still communicating with the backup router. In this scenario, you can configure tracking interface. So you can configure on VRRP to tell it to monitor this interface. And if something happens to this interface, if it goes into a disabled mode, a shutdown mode, or any form that's not an enabled mode, what will happen is it will actually lower the priority to whatever you specify. You can change it to 10, 20, 30, 40, 5 if you want, but the default value, if you don't specify a value, is 10. Then your priority will change to 10 if this interface goes offline for the master device. So in this scenario, all the traffic flows in this direction, and this link is now disabled. Your priority will change to 10, meaning you will become the backup router, and the backup router will become the master router. And now that the backup router is the master router, your traffic will be flowing in this direction, and this link is still okay. So that is all good. You will continue to communicate with your ISP. Okay. Then we have load balancing. So this is where we want to get to with VRRP. So if you have two routers within your network, you don't want one to do all the work. Even though it's for redundancy purposes, that's fine. But if you can split the load, you want to split the load between your devices. So you can have two VRRP groups. You can have VRRP group 1 and VRRP group 2. It's important to note that you will require two different gateways, so probably you will require two different VLANs or SVIs. So you can see here we have a PC on VLAN 10 and a PC on VLAN 20. So what will happen here is on your switch A, you will configure, there's two ways of doing it. So the way that this image has shown us that it did it is if you look at SVI 10, the IP address is 192.168.10.1. And if you look at the gateway for VLAN 10, the IP address is 192.168.10.1. So this means that SVI 10 or this switch here is the IP owner. And now that it's the IP owner, it automatically means that its priority becomes 255. So because its priority is 255, this switch will be the master for this entire network, for VLAN 10, that entire network. And if you look at SVI 20 on switch B, the IP address is 192.168.20.2, and you can see the gateway is also 20.2, which means this becomes the IP owner as well. And the same thing follows as what it did with switch A. IP owner and the priority equals 255. So this becomes the master device for group 2. So now, in theory, all the traffic for VLAN 20 will flow in that direction, VLAN 20, and all the traffic for VLAN 10 will flow in this direction over here. So now you have two routers, two networks, they are a backup for each other, and they're doing load balancing. Okay. So that's it for the VRRP principles. Do you guys have any questions about VRRP? Perfect, thank you. So we will continue. Okay, so now on to the second step. We have completed VRRP principles. Now we're looking at MSTP principles. So first of all, MSTP, we won't go into too much detail regarding MSTP because MSTP is built on top of STP and RSTP. So STP and RSTP. So STP spanning tree protocol, RSTP a rapid spanning tree protocol, and then you get MSTP, which is multiple spanning tree protocol. So multiple spanning tree protocol is just built off of RSTP. So I'll just be covering the additional functions that MSTP does with RSTP. So if you look at RSTP, some shortcomings for RSTP, for example. So for people who might not be familiar with RSTP or STP, what it does is it is a loop prevention protocol. So it's a layer 2 protocol. It works on your layer 2 network, and it prevents loops on your network, as well as give you redundancy capabilities. VRRP has mentioned this in his lecture before mine. So what that does is, if you look at this network on this slide here, you will see we have 4 switches and there is a loop on the switch. So what RSTP will do is it will elect one root device. So for example, switch 1 will become your root device. And now these switches will communicate with each other with BPTU packets and interface costs and all of that to determine what interface should be blocked. So at the end of the day, this interface will be blocked, or in this scenario will be blocked. So that means that if you want to communicate from switch 4, you will follow this path like so. And if you want to communicate from switch 2, you will follow this path like this. The shortcoming that STP has is it is once it's run, this is your network topology for the entire network. It doesn't matter if it's for VLAN 1 to VLAN 100. This is your topology. You cannot change it. So what MSTP allows us to do is it allows us to run instances based off of VLANs, which we will touch on now. MSTP is an abbreviation of multiple spanning tree protocol. Multiple spanning tree protocol are based on the instances, and load sharing is achieved between instances. So as you can see from the diagram here, this is the same network. We just have 2 separate instances of spanning tree working. So on instance 1, we have linked to VLAN 1, 3, 5, and 7 to instance 1. So now that we have instance 1 linked to these VLANs, we told the topology that switch 1 should be the root for instance 1. And now that this is the root for instance 1, you will see the following will happen. So the switch here at the bottom, switch 3, has a direct connection to the root switch. So that means that is a root port. And because that is a root port, this port cannot be blocked. And if you look at this one, switch 2 has a port, root port to switch 1 as well. And then it has a designated port. This port will then be blocked. So because this port is blocked, so for instance 1, VLAN 1, 3, 5, and 7 will use the left-hand side to communicate. And that's how you will achieve load balancing for VLAN 1, 3, 5, and 7. So now if we look at instance 2, so instance 2, we have linked VLAN 2, 4, 6, and 8. And now that VLAN 2, 4, 6, and 8 is linked to instance 2, we made switch to the root for instance 2. And now the same path, the same principles will follow. This is the same network. These are all one in the same switches. It's just to explain to you guys how the instances work. This is one network. Just keep that in mind. So now that you have one network, your switch 2 will be the root. So this will be a root port, and this will be a root port, and that will be a designated port. So this port will be blocked. So as you can see here, now from this image here, VLAN 2, 4, 6, and 8 will communicate over this link in that direction to its root port. But if you look now back at instance 1, so if instance 1 is also on this image here, so let's just do instance 1, it will actually communicate over this link in that direction. So for a total of 8 VLANs, we have segregated them into 4 VLANs. So this link will handle 4 VLANs, and this link will handle 4 VLANs. And that is a bit of load shedding, not load shedding, load balancing with MSTP. All right. So MST regions. So multiple spanning tree protocol works in regions. MST device switches networks into multiple regions. Each region has multiple independent spanning trees. A spanning tree comprises multiple switches on a switching network and the network segments between them. A LAN may have multiple regions which are directly or indirectly connected physically. A MSTP network contains one or multiple MSTP regions. Each region contains one or multiple MSTP instances. During a routine project implementation, network maintenance, a LAN only has one MSTP region generally. Devices in the same MSTP region follow the following features. So what all of this means is, by default, you would only have one MSTP region. So for a big network like this, even though you have one region, you can still configure different instances. But you can also segregate your network into different regions with MSTP configuration. And the way to do that is to specify a region. Your cluster of switches will have to have the same configuration as you can see here. So configured with the same domain name. So for example, let's say this is sales. So if you configure MSTP on all of these 4 switches, you will go into MSTP configuration and you would say name equals sale. So now these switches will belong to the same region. You have to ensure that the same VLAN instance mapping is enabled as well, and the revision number for all of these switches are the same. But you can do it on this region as well. You can make the name support, for example, and now they will belong to the same region. On this side, you can make it admin. And for example, here we can do finance. And that's how you can accomplish different regions within the same network. Each region can run different instances of STP as well. Okay, so MSTP instances. A MSTP region may have multiple spanning trees, and each spanning tree is an instance and identify using an instance number. So your default instance is instance 0, and all VLANs in MSTP is linked to instance 0 by default. You can then have up to from 1 to 64 instances in total. So 64 instances you can configure. So what's important to note by this statement here is you can have one instance, so instance 1 equals VLAN 10, 20, and 30, for example. So you can have multiple VLANs linked to one instance. But what you cannot do is you cannot have instance 2 and connect VLAN 10 to it as well. If you connect VLAN 10 to it, that will not work. So you can only link one instance or one VLAN to one instance, but you can link multiple VLANs to an instance. So as you guys can see here, this is what we discussed a bit earlier. Via instance 1 will use this link, so it will use that link over there. And instance 2 will use the other link. Instance 2 will use this link here. So that would be that link over there. And that's how you can have backup links, but utilize them at the same time. Okay, then common spanning tree. Okay, so what this means is when each MSTP region is regarded as an independent node, a common spanning tree is generated based on these nodes. So when you have different regions, like we've explained previously, these regions are seen as one device. So between these regions that are seen as one device, you also require a spanning tree to run between them to prevent loops. So what you can see here is this port or this one here was probably blocked to prevent loops from happening between your regions. This is what common spanning tree is. Internal spanning tree. So internal spanning tree in multiple spanning tree is a common spanning tree instance within a region to ensure loop-free connectivity for the VLANs within the region. So all that this means here is that you can configure your instances. So you can configure instance 1, 2, 3, and 4, for example, but there's always an instance 0. And instance 0 looks like this. So instance 0 equals VLAN 1 24096. So instance 0 will always include all the VLANs. And if you create a instance 1, for example, with VLAN 10, all that will happen is VLAN 10 will be removed from here. So your instance 0 will then change from 1 to 9 and comma 11 to 96. So just to give you an idea why this is necessary is, let's say you have 10 VLANs and you configure an instance for 5 of the 10 VLANs. You don't want the other 10 VLANs not to have an MST or a spanning tree connected to them, because you don't want to loop on that network. So that's why instance 0 exists, to prevent that from happening. So then it's like a fail safe for your loop prevention protocol. And then just some other related concepts. MSTP port roles, you get a root port, designated port, an alternate port, a backup port, an edge port, a master port, and a region edge ports. And this is only applicable when the regions within your network, if multiple regions within your network exist. And then you also get 3 port states, the same as in RSTP. You get forwarding, learning, and discarding. Okay, so that's it for MSTP. I don't know if you guys have any questions at this point in time. Thank you. Okay, so now just to the practical work that we'll be doing. So to give you guys an idea, this is the topology that we will be dealing with. So we're going to have a ISP router. We're going to have a switch. We're going to have a link between the switches. And then we're going to have another switch here and another switch here. And the reason, what I just want to say is, anything from this point up is considered routing or ISP territory. WAN maybe would be the right wording. And this side would be our LAN. So our goal would be is to configure VRRP on these two devices. So we're going to have 4 VLANs, 10, 20, 30, and 40. And on this, we want this one to be the master for 10 and 30. And this one to be the master for 20 and 40. And obviously backup for, so this one will be backup for 20 and 40, and this one will be backup for 10 and 30. So that's what we want. But then for MSTP, we want this link here to only allow VLANs also 10 and 30 to go through there. So we're going to have 2 instances of MSTP running. And on this side, we're going to do 20 and 40. So obviously they will be backup for each other, but primarily we want 20 and 40 to go over this link and 10 and 30 to go over this link. So this is just what I want to accomplish, and we will have PCs connected to the network. I just quickly wanted to draw this out for you guys before we start configuring. Okay, so you guys can still see my screen, I believe. Can you see the topology I have here? Thank you. I'm assuming that if I don't get a no, that the answer is yes. Okay, so first of all, let's look at the topology once again. I've actually already configured the IP addresses on the PCs here just to save us some time in the near future. So what's happening here is we have our ISP switch, we have our 2 core switches, we have our access switch. As you can see, all these PCs are connected to the access switch, and they are 192.168.10.1, 192.168.20.1, 30.1, and 40.1. Their gateways belong to 10.254, 20.254, 30.254, and 40.254. So we need to do the following: master for the 20 and 40 range on this side, and master for the 10 and 30 range on this side. And then we can do some testing afterwards. So let's just get the ISP router up and running real quick. Let's just do the configuration. As you guys can see, I'm logging into this router now. Okay, so first of all, I always like to have a good idea of what device I'm working on. So all switches will be named Luigi, and that might confuse me in the future. So let's just give this switch a name. We're going to do it ISP SV01. And there we go. Now the host name has changed. Now that the host name has changed, we can configure a loopback address. This is just for some routing demonstrations that we might show you. So a loopback address is an interface that will never go offline, so you can always just route to it. So let's go interface loopback 0. Now I've created interface loopback 0, and now I can just configure the IP address on it. Bit delayed today, sorry about that. Okay, now I have the interface loopback address configured. I can say exit, and now we have to log into these two interfaces and configure a point-to-point link for our LAN devices to connect to for internet breakout. So as you can see from the routes on this side here, 192.168.10.0/24 is reachable over 10 and 11.0.0.1. So .1 will be configured on these switches here. So that means that the IP address on these interfaces have to be 2. And I will explain to you guys now why we have 2 routes. Inter gigabit 0.0. And this is a switch by default, so we have to change it from a switching interface to a routing interface, a layer 3 interface. So we say no switch port. So no switch port. Okay, now it's a routing interface. The main reason I think it's currently a bit slow is because there is a loop on the network, because we haven't configured MSTP yet. So I think this is why the switch is slow to respond, but we've just broken one of the ports at least. So now we can configure our IP address on this side. So this is going to be interface gigabit 00. So we're going to make it 10.0.0.2/30. Okay, now that we have that interface, we can log into interface G001, which connects to switch B, and we can do the same, no switch port, to remove the switching interface. Now it's a routing interface, and we can give it an IP address of 11.0.0.2/30. Sorry, /30. Now that we have that IP address, that is working. Now the last thing we need to do on the switch is create the routes. So as you can see, for each network, I have 2 routes. And the reason for this is because this is the master for 10 and 30, you will see that my distance is 1 to go to the switch here, and my distance is 100 to go to the switch here. So that means if this switch fails, then the router knows how to reach it via another route. And if this switch goes offline, this switch will actually be aware of it because the interface will go offline as well. So to show you guys just how to add those routes. So this is a switch. So I just always like to confirm that routing is enabled by typing in IP routing. That just enables routing on a layer 3 switch. But we can add our routes with IP route, and then we can say 192.168.10.0, and we have to put in the subnet mask physically, so 255.255.255.0, indicating a /24, and then we can say over what interface it should monitor it. That is 0.0, confirm, yeah, 0.0. And we can specify the IP address as well, which is 10.0.0.1. So this is going to be our default route or our primary route. So there's no need to indicate that we have to put a separate distance on it. Now that we have done that, we can just say show this, for example, or this. Show this. You will see that the route has been added. Okay. Now let's just add the backup route quickly. So it's IP route 192.168.10.255.255.255.0 GI0.1, because now we have to route over the other interface here to go to switch B, because this is my backup route for this range. That's going to be 11.0.0.1, and we have to specify the distance. So if we specify distance, it has a higher distance, so it's not the preferred route. The route here would be the preferred one, because I think the distance is 1. So if we say that, you say show run, show this, we will see now we have both routes active. So just to speed up some configuration, I have just copied all of this into a notepad so that we can just copy paste, so that I don't have to do it for all 4 ranges. It's going to be time consuming and a bit boring maybe. So I can just paste all of those routes in there now. And now that all of these routes are pasted in there, show this, you will see that I have 8 routes. So 192.168.10, I have the route, the primary and the secondary route. And for 20, you'll see that 10.0.0.1 is the secondary route and 11 is the primary route. And for 30, it's the primary route is 10 again, and the secondary route is 11. And for 40, 10 is secondary and 11 is primary. Okay, now that we've done the routing on this router, we are all good. And we can save the configuration. So let's just save the configuration. So that's fine. Now we can move over to our 2 core switches. Let's log into both of them real quick. Let me just do this. Okay, so now that we have both switches, we can still see what's going on here. So let's open up configuration 1 first. To enable, we have to just do the password. Now that I'm logged in, we can go into config mode and we can specify the host name. One word, apologies. And this is for SV01. All right, now that we have this host name, this switch here already has no host name as well. So we can just go enable, type in the password, and then we can go configuration. Okay, host name. We can just say for SV02. Okay, now we have our 2 core switches. Now let's just get the routing up and running. So we can say interface GI0/8, because that is my uplink interface, as you can see there. And we can say no switchboard, because this is going to be a routing interface. And we can give myself the IP address of IP address 10.0.0.1. That is my IP address. The ISP routing is routing to this IP address. I can just do this. There we go. Now I have that IP address, and I can say exit. And once again, just confirm that IP routing is enabled, because now I will create a default route to my ISP router, like you would do in any circumstance. So IP routing is enabled, and now I can say IP route 0.0.0.0. There. So that's all the addresses, and the subnet mask is everything. And I can specify the interface GI0.8. .8, and I can specify the IP address, so it's going to be 10.0.0.2. And this, let's check. Okay, so it is enabled. The route is there. And now we can do a ping test real quick to 1.1.1.1 and confirm that the routing is working. So I can ping my loopback address from the switch. Let's just quickly do the same on this switch, this side. So config T, I'm in configuration mode. So, inter gigabit 0/8. No switch port, changing it. Okay, no switch port. And then we say IP address 11.0.0.1/30. And then we can put exit. IP routing, just to ensure that routing is enabled, and IP route 0.0.0.0.0.0, GI 0/8, and 11.0.0.2. So we can confirm this is working now by doing a ping test one more. There we go. And theoretically, I should be able to ping switch B on its WAN IP address as well. So there we go. Okay. Now we have the WAN side sorted. Now we can do the LAN side. So first of all, on the LAN side, I always like to start off with layer 2 before we move on to layer 3. So what I mean by that is we're going to sort out the loop on the network before we start figuring out the routing. So like you guys know, there is a loop on this network. So, and we're going to use MSTP to prevent this loop from happening. So currently, there's the triangle. So one of these interfaces has to be blocked. So let's just do this quickly. So I want to create 4 VLANs. So let me just create the VLANs before we do anything else. So as you guys can see here, these are the VLANs that I will be creating. So VLAN 10, 20, 30, and 40, sales, support, admin, and finance. All right, so let's create these VLANs real quick. The way you can create a VLAN is quite simple. You can do it in one or two ways. If you don't want to give them names, you can say VLAN range, and you can put in 10, 20, 30, and 40. And there we go. We have created the 4 VLANs. I like giving my VLANs names. So I just do it this way, and I give them names. So on this side, I will do the same. Let me just do this. So this. You can see I've created the VLAN, and now it has a name. And if I do show run, you will see there's my VLAN, VLAN 10, 20, 30, and 40. So let's do the same on this side here. Config T. Let's create the 4 VLANs. Paste. Okay, perfect. Now the 4 VLANs have been created. And now on our access switch, we also have to create these VLANs. So let's put this one in this corner here. And then we can just zoom out here for now. And then we can still see what's going on here. So on our access switch, let's create the VLANs as well. Okay, so we're in configuration mode. So I just want to give it a host name. This is going to be my access SV01. So now that it's the access switch, that is fine. I just want to create the VLANs on them as well. So on this one, there's actually 2. So if you look at the diagram here, the PCs connected to this switch will have to be connected via access port. So access port will theoretically put you on the VLAN that it's an access switch port 2. So this would be access 10, access 20, access 30, and access 40. So there are multiple ways of accomplishing this. The number one way is you can do it like so. So we can go, let's just create VLAN 10 quickly. VLAN 10, that's how you create the VLAN. You just type in VLAN 10, you give it a name, and the name is sales. Right, now that has a name, you say exit, and you can go to the physical interface. That is gigabit 01. Once you logged into the physical interface, you can say switch port mode access, switch port access, VLAN 10. Right? You can do that, but that is quite a long way of doing it. Or you can do it like this. You can go to, so now we've done VLAN 10, let's do VLAN 20. So VLAN 20, now VLAN 20 has been created. We can give it a name once more, support. And you can say add interface GI0.2. And now you've actually added this interface. So if I show running configuration, and we go to interface 2, you will see that it's been added into VLAN 20. So that is quite nice that you can add an interface through there. Right. Let's quickly do the other interfaces then. So once again, I have made it a bit easier for me. I'm just going to paste the configuration in here. So all that you can see I'm pasting is VLAN 30, admin, giving it a name and adding the interface to it, and 40 as well. So there we go. Now I've added those interfaces. So if you say show run, you would be able to see what I mean. So 10, 20, 30, and 40. Good. That's perfect. So let's continue. So now that all the VLANs have been created, the interfaces have been assigned, we still need to do the trunking interfaces, but we can do that after the configuration has been completed for the MSTP. So let's do MSTP first. So first of all, you would initially want to enable spanning tree, but I like staying spanning tree mode MSTP. So I like changing the mode to MSTP before I enable it, because then it works on the correct mode immediately. So MSTP mode, just going to do the same on all the switches, spanning tree, MSTP, sorry, not mode, MSTP. This way, and this way as well, spanning tree, MSTP, mode, MSTP, right? Okay, now we can enable spanning tree. And now there's a lot of messages that's going to run. So let's just give it some time to finish quickly. So now spanning tree has been enabled. So let's just give it a time to quickly send all the BPDU packets and establish the regions and the main MSTP mode and block the relevant interfaces. So this is MSTP instance 0 running now. There's one region, there's one instance, and that's 0. So we do a show spanning tree summary. You will see that we actually have it running. It will show us what device is the root device. This device is actually the bridge device, but you can see the priorities are still all the same. And if you do it the same on here, show spanning tree summary, you will see that it tells you this is the root port and all ports are in forwarding state. And show spanning tree summary, you can also see that port 8 is being blocked. So this is important. So this is for instance 0. So port 8 is being blocked. So this port here is being blocked. So the traffic is flowing in this direction. So there's no more loop on our network. But now we want to create a single region and 2 instances and different routes for MSTP. So switch 1 should be root for VLAN 10 and 30, and switch 2 should be root for VLAN 20 and 40. So on this side here, we will go spanning tree MSTP configuration. So now that we are in the configuration tab, now we can confirm a few things. So once again, we can give it a name, like I've mentioned earlier. The name will specify the region or the domain, the name. So we're just going to call this easy. We're going to make it Ruji. And now changes will occur because you've made a change. So it interrupts the current region so that everything is connected to. So now that we have that running, we can create instance 1 on the switcher, instance 1 VLAN, and we can assign the VLAN. So on instance 1, I want to assign VLAN 10 and VLAN 20. Okay, now it's made the changes. Now, if those instances are assigned, I can give it a revision number. So it's important to note that all revision numbers have to be the same, and you can choose any number between 0 and 65,535. The default value is 0. The revision number just informs the other switches that might be part of this region that this is the latest version. So we'll just do revision 3, and that's done. Now we have configured that on our main switch. So I've just typed in exit. So now we have our instance, or well, our region running. Now that we have our region running, we still need to specify that this core 1 is the root switch, or yeah, the root switch for MSTP instance 1. So what you can do is you can do spanning tree, MSTP, MST, then you can say instance. You can just specify the instance. You don't have to type instance. You can just specify the instance. So instance 1, and you can type in the priority. And for instance 1, this should be primary. So we're going to make it 4096, which will make it a root for this instance. And then we have to specify that it should be the backup root for spanning tree instance 2. So MST instance 2 priority 8192. And now it has that priority. Both of these switches are still on the default priority. So we need to go ahead and change that now. So now we're done on this side. So on this side, once again, let's go into spanning tree MSP configuration. We're going to do a name. It's just Ruji. Now we're just going to get some messages. That's fine. Come on. So now we're going to do instance 1, VLAN 10 and 30. Instance 2, VLAN 20 and 40. Right, and then the revision number is 3. So let's just do the following. Let's just show this. So it's showing us our configuration that we've just done. Obviously, I'm getting a lot of messages because it's syncing with the switch 1 now on that side. So these packets are actually good news for us. That means that they are communicating. It's name, instance 0, like I've mentioned, and then the VLANs that are relevant. That is fine. I just want to confirm something on this switch real quick here. Okay. So I made a mistake on my MSTP configuration here. I do apologize, guys. Just give me a moment to fix that quickly. You can see I never added instance 2 on this switch here. So, and I also added the wrong VLAN there. So this is how it's supposed to look. This is how it looks. So let me just quickly fix that, please. You can add instance 1, VLAN 10, and VLAN 30. Okay, that is correct. And we can add instance 2, VLAN 20, and VLAN 30. Okay, this looks correct. Now, let's confirm that they both look the same. Yes, okay. Sorry about that, guys. I just realized that as I was configuring the switch on the side. So, back on switch core 2, we can say exit, and now we have to specify its root priorities here. So, spanning tree MSTP instance 1, your priority should be backup for instance 1. So it's going to be 8192. That's going to be your priority. The priority on switch 1 is 4096. So we say enter there, and we go back to this configuration here, and we select spanning tree MST region 2. We'll make you instance 2 priority for instance 2, so 4096. And there we go. Now this will become the root for instance 2, and this will become the remainder root for instance 1. Now back on switch 3, just to get this quickly, is spanning tree MSTP configuration. On this one, we just have to do the configuration. We don't have to specify anything else. So let's add it to the same region. So name, region, instance, that's right, instance 1, VLAN 10, 30. Okay, then instance 2, VLAN 20 and 40. Okay, now that they've been added, we just have to add the revision number of 3. Now MSTP has actually been configured. Let's just wait for all the forwarding packets and interfaces to be set. And once we have a stable command line, I can show you guys. Okay. So if we do show spanning tree summary, you will actually see. So this is the instance 0. So not VLAN 10, not VLAN 20, not VLAN 30, and not VLAN 40. So we have not changed this. This is that default IST that I was talking about that will continuously run. Right? Now I have MST instance 1, VLAN 10 and 30, and you can see the priority. So this is the bridge for this one here. You can see all its interfaces are in forwarding state, so that's perfectly fine. And then for MST version 2, you can see this is my bridge ID. This is the physical switch ID. So that means that this switch is actually the root to it. You will see that it also has a root port. So port 7, and if you look here, port 7 is the root port. The root port indicates that it is the port that is connected to the root of MST. Okay, so that's all good. And on this side, we will see the same. I will just show you guys briefly. So let's just go through this. MST 0, I'm not going to care too much about this. So this is the root's priority, but my priority for this switch here is actually 8192, and then it will show you the rest. And the important one for this one is MST instance 2. This is the bridge, and then you can also see all the ports are just designated ports in forwarding state. The important one that we need to check is this one. So show spanning tree, summary. Okay, so this is the important one to check. So we don't care about instance 0, so instance 1 is important. Port 8 on instance 1 is being blocked. Port 8 there, so instance 1 is being blocked there. That means VLAN 10 and 30 will go in that direction. If we continue to have a look here, we will see port 7 for instance 2 is being blocked. So now this port is being blocked, so VLAN 20 and 40 will go into this direction. And this is how you get, this is how you establish load balancing with MSTP. Okay, so that's the MSTP configuration. I don't know if you guys are happy with that, because I need to move on to VRRP. Okay, let's move on to VRRP. So for the VRRP to work, we just quickly need to configure the trunk interfaces. So let's do 7 and 8 on this switch. So interface, range, 0.7.8. So now we just log into both of these interfaces, and we can say switchboard mode, trunk, switchboard, trunk, allowed, VLAN only, 10, 20, 30, and 40. So now over these two interfaces, I'm only allowing these VLANs to go across them. So that's fine. Now I've done the trunk interface. Now I have to do it on the core switch as well. So that's 7 and 0. So we can go interface, range, GI, and yeah, there we go. So I'm logged into both of those interfaces now. Switch port mode, trunk, switch port, trunk, loud, VLAN only, 10, 20, 30, and 40. Right? And just on this switch as well. But the nice thing is you can copy paste these commands now. They would work. Let's just confirm they are the same interfaces. So that is fine. Okay, now we have our trunk interfaces up and running. Okay, so from this point on, it's not necessary for the access switch anymore. So we can just do this. Again, yes. That doesn't matter. Okay, let's continue. So now that we are logged into both core interfaces, we have to configure the gateway, config T. So we have to go into the VLAN for the gateway. So enter VLAN 10. Now that we log into VLAN 10, we can actually show you guys the following. So we can configure the IP address on this device. So this won't be the physical gateway for the networks. As you guys can see, the gateway is 10.254. No, we wanted that to be the VRRP side. So let's just do this. So IP address 192.168.10.252/24. So this is my IP address on this side now. And let's just configure the other side here as well. So enter VLAN 10 IP address 192.168.10.253/24. Okay. Just quickly want to log into this PC and show you guys how this would work. Okay, so show, let's just see, yeah, I have the IP address there. So ping 192.168.10.252. Here we go. I can ping 252. And I can ping 253. But I cannot ping 254 because obviously I haven't configured the IP addresses yet. So how this works is quite simple. You have your interface configured. So on this, your core switch or your primary switch, your master switch for this VLAN, you would configure VRRP. You would set the priority or the VRID. Now you can do the priority. So VRRP 10, that's your VRID group. Priority, this is the priority I'm giving you. Right, now it's been created. Now you can say VRRP 10, you specify the VRID again, and you can say, I want to configure a IP of 192.168.10.254. Now this has been enabled, so you can see that this device went into backup mode because it required to send the VRRP packets first, and then it changed to master state. So on this side, let's just do the same. Before we do the same, let me just show you something else. You can do VRRP 10 track. So you can track the interface. If this interface goes offline, its priority will lower itself. So GI 0-8, and then like I've mentioned, you can specify a value, or you can just press enter and we'll change it to 10 automatically. But let's make it 20. Okay. Let's configure VRRP on this side. VRRP 10. And we can just put the IP address because the default priority is 100. So if we just put the IP address in here, it will actually pick it up. So you will see it goes into backup state and it will remain in backup state. It will not change. So if you do the following, show VRRP brief, which will allow us to see our VRRP, you will see that this is the master state and the master address is 10.252. If you do show VRRP brief on this side, it will do the same. it will show that this is the backup state. The master address is that. So it is quite clear about that. And now on our PC, we are able to ping 10.254. Okay. And then just to do the last one, I want to show you guys how this works, is enter VLAN 30. There's a reason I'm skipping 20 for now. It's just due to a bit of time constraints. So I'm just going to 30 to show you guys that you can do 2 VRRP groups on both sides. So now that VRRP 30 is online, we can show IP. We can give it an IP address of 192.168.30.252/24. And on this side, we can just do the same, enter VLAN 30, IP address 192.168.30.253/24. Right. Now that we have both of this running, as you guys can remember, okay, this one should also be the primary root, the master device for this range. So IP address, sorry, so VRRP 30, we can say priority 150, and we can go IP VRRP 1030, IP 192.168.30.254. Now this will go into backup state and go back to master state quite immediately. Now we can do here VRRP 30, and we can just add the IP address into this interface here. It goes into backup state and it will remain like that. Now just for the last VLAN, let's do VLAN 20. Interface VLAN 20. Interface VLAN 20. Okay. That's IP address 192.168.20.252/24 and IP address 192.168.20.253/24. I want this switch to be the master for this network. So because I want that on this switch, I'm just going to configure IP, VRRP 20 IP 192.168.20.254. Now that I've configured that, you will see this switch will go into backup mode, then it will go into master mode. I haven't changed the priority yet. So on this switch on this side, I want it to go into master mode. So we go VRRP 20 priority, and we will make it 150, and then we go IP VRRP 20 IP 192.168.20.254. Once I've done that, you will see it goes into backup mode, and then it goes into master mode, and you get the notification on this side as well that it has gone into backup mode. All right. Okay, so that's how you configure VRRP. I haven't done VLAN 40 now, but that is okay. I just want to demonstrate to you guys how failover will work. So to give you guys an idea how the failover will work, you will see we are logged into, let's just show, we are logged into PC on VLAN 10, so this PC here. And if we ping our gateway 192.168.10.254 continuously, it will ping. But now to test that, to test our MSTP, redundant links, and our router redundancy and everything, let's turn this router off to confirm that all of this works. Let's do a real life test real quick. Let's stop this from, let's just stop this switch because this is the current gateway. So I've stopped it. There we go. And that's how quick the VRRP does failover with your MSTP as well. I lost 2 packets in total before the core switch 2 became the master device, and the STP links also switched over, MSTP links also switched over to port 8. Thank you guys. That is me. If you have any questions, please do let me know, and I'll happily answer this for you as well.